Right here we click that. That is our RPM sensor right here. It's got power to it. That's going to be on the spindle. Our next RPM sensor is right here. That is for the feed rate. And then this button here, that gives us motor power. And notice it is rotating counterclockwise. So when I kill power, initiate the reverse switch, and reconnect power, now we're rotating clockwise. And then with the pulse width modulator, we can crank up the speed. And this is about 67 RPM here, and we can turn it all the way down to a crawl. And it's still got torque at a crawl. I mean, I can still not hold on to that. So yeah, it's still pretty torquey. So I think it'll work really nice for that lead screw. And that's all done with that set of 3 relays. The only thing with this is there's a potential that you could back flush power the wrong direction. So every time you initiate reverse, you have to make sure you cut the main power, initiate the reverse, and then add power again. So this lead screw right here, that's what we're working with. So this bracket was broke when I got the lathe, so that needs fixed anyways. And this fits on here and the lead screw turns. We need to machine, well, somehow we need to get this motor to connect to here. So, okay, alright guys, so what we're doing is I need to mount this motor up here to the end of the lead screw. And it's a little tricky because this gear pressed on, this shaft does not, actually, yeah, this shaft does not spin. Gear has teeth that go down inside that spin. The gear is the only thing that spins, so I can't just turn the shaft. But I have another one of these motors with the same exact gear, so I should be able to mount it up next to it, and then if I can get this gear onto here, then we're good. But this is hardened steel, so I can't tap it, and I don't want to heat it up and kill the hardening because then it might wear down on those gear teeth. So what I need to do is, this mount was broke with the lathe, so I'm going to make a new mount. There's 2 holes to attach, and then I'm going to turn this, drill it, thread it, and then screw this on, and then I'm going to turn the other side, so it's like a, maybe 2/1000 or 1/1000 bigger than this, and then I'm going to heat, or actually I'll cool this down a little bit, heat this up a little bit, not enough to kill the temper, but enough to make it expand, and then I'll press this on, and hopefully that differential heating will lock this thing on tight where it won't spin, because I don't want to try and drill it either because it's hardened. So yeah, hopefully that differential heating will lock this on, and then I'll thread the rest of it, and then I'll mount that there, and then on this side I'll mount a plate to here, and then make an angle bracket that I can bolt it in, and then I got to get it set just right so this will ride on there, and then that'll also double as a locator. Well, actually, I might have to make something to locate that too. Maybe another little bushing that slips on there. But yeah, so that's the plan. So I'm just getting this thing barely in there, and really just, I think it's 1.5 times the diameter is what you can have for stick out, but really just doing just enough to get the indicator on it. Okay. So we're a little high here. So what I'm doing is I'm going to my high spots and I'm tightening those down. So it's a little high here. Tighten that down. Low here, so I give that just a little bit of a loosening up. So a little bit high. Go back over here where we're high. Tighten that a couple thousandths. Okay. So take a look here at the dial. We're within 10 to 11 thou there, maybe just a hair over, so yeah, about within a thou. That's plenty good enough for what we're doing here. So get this set up. First thing I'm going to do is face this guy off. So I'll face it off, get a center drill in there, and then we'll drill this thing out. And I got to be real careful on this not to drill too deep, because on the other end there's going to be a stub that's sticking out, so I got to really watch my depth. So that just a little bit. Yep, this tool not leaving too hot of a surface finish, but it's alright. Center drilling this guy. Just a little bit. Now I'm going to get so this is a 3/8. So the end of lead screw is 3/8, so therefore we need a 5/16 tapping drill. So I'm going to drill this out to 5/16. Okay, so now I got that guy started. Should be nice and square. I have to do the rest of my turning operation on the other side. So I'm going to pop this out of the lathe and finish tapping it on the bench. I'm just going to keep getting the chips out of here. Keep them from binding up. There we go. Now let's throw this back in the lathe. So coming in, I'm just going to touch off here. Alright guys, well, plan was to press fit this, but I took it like 1,000th too much, and it is just tight, but well, I don't know, we'll see. It might be on. I thought I went just a little too far, but we'll see. Might have to, I was planning on doing an interference fit, but we'll see. Might have to somehow add like a set screw or something. So that's our piece there. Okay. I'm gonna have to measure the distance that this lead screw is supposed to. Actually, I can put the old. This was the old bracket that was broke. Yeah, I'm gonna have to set that up there and measure that distance. And then I'm probably gonna have to turn another bushing that's bored out to 3/8, and then replace this, and then I'll probably take that and weld a bar that goes up to here that'll hold that all square, and or something from the bottom. Maybe I'll have this plate sit just right on something and then I can weld that on. Yeah, pretty happy with how that's looking. And it's just a matter of mounting this thing somehow. If I put it up here, this hole will contact the lathe way. So I think realistically, it'd be something like this. Yep, something like that. So, alright, she's getting there. Alright guys, so over here, I got the lathe, I got the control panel set up. I went through a little bit of the wiring on that, but I got the motor hooked up to the power feed. I was just kind of going to run you guys through it and show you how I did it and how it works. So here we go. Alright, so before I turn it on, basically we have power running in the lathe here. That's nothing goes through the controller. The switch right here powers the lathe on, and then our this box here has a separate power feed, and the first readout here is for the digital RPM sensor. Okay, so this first sensor here, I'll power on the lathe. So the lathe is now turning. Initiate this here. That is our RPM of the spindle on the lathe. And then this sensor here detects the RPM of the lead screw. So, and these just have these little magnets that you mount. Those little magnets, you just mount them wherever you want to detect speed, and then it'll tell you the RPM. So I have another one mounted back here that sensor's reading there. And then over here, this motor is out of an old GMC Jimmy. It's a power window motor, and as you can see, I fabricated this little bracket. There's just a pin going through here, or a bolt going through there, that allows this to pivot. I have it tightened down where it needs to be, so that the gears will function. So So yeah, that little power window motor just turns this gear here, and what I did, I took a piece of 3/4 inch stock, turned down the end of it, and then pressed that gear on, but then it started to slip, so I had to weld it just a little bit. And it didn't weld very nice because of the composition of that gear, but it was enough to hold it in place. So I wasn't tickled with how that came out, but it was all right. And then this lead screw here, I turned down the inside and then threaded it to 3/8 threads, and then I put some set screws in. And I don't have a milling machine, so I put a 1/4 inch end mill in the drill press and milled some flats, and then finished it up with a hand file, got as close as I could, and then drilled and tapped those and there's 2 set screws in on the other side. I put 4 in because this shaft was kind of bent, and I kind of used the set screws almost like a 4-jaw chuck on the lathe to kind of like, I put an indicator on this and got it as close as I could with the different set screws, because again, this was a little bent. Then I just turned this bushing here down to the OD of this rod, and that now locates the rod, because the old mount was actually broke, and then I used the old original mount holes there. So, and the weld's not too pretty, but I kind of had to build it up a whole bunch because this was not flush with the face. But yeah, I got it pretty true. It runs nice, and yeah, I'll show you. I'll turn it on now and show you how it works. So we've got blades on. We have our spindle RPM here, and then this is the RPM of the lead screw. So this initiates reverse. We have our pulse width modulator that controls the speed. We can speed it up, slow it down, and then this initiates the forward control. So now we have forward control, and again, varying the speed on that as well. So yeah, I was pretty tickled with how that came out. The gears back here, they chatter a little bit just because I didn't get it exactly perfect, because again, I've got a plate that was fabricated, welded on, and then I've got a bolt through that's tightened down that's holding that whole motor apparatus. So the whole thing, there's a little bit of inaccuracy in that, and they chatter a little bit, but I greased them up, and I think they should be fine over time. And the lead screw, the end of it, I indicated it, and it was actually a little bit bent from whoever damaged it before. So I think that leads to a little bit of the chatter in the gears, but other than that, it works really stellar. And the whole cost of it was about $80 in electronics to build that control panel, including the project box, pulse width modulator, like a transformer to convert it into DC. And then that little motor I got for free, I just yanked it out of an old car we had around here. And again, it's just a 12-volt power window mirror, so works super good. And it's got a lot of torque for that little motor, because it's spinning a couple thousand RPM or something like that inside, and then there's a big worm gear that reduces it way down. So that thing turns really slow and has a lot of torque despite being a small motor. And again, it was free, so instead of having to buy a DC motor off the internet for $60, that was free. So, and I have a couple other motors here that I pulled out of that car. This motor here was the rear windshield wiper, and I was hoping this one would be set up a little differently. It's got a cam that controls those 2 like teeth there inside, and that causes the oscillation of the windshield wiper. So it's not ideal. The output shaft oscillates, so it's not ideal candidate, and there's not really a good way to connect in here. So again, that was the rear window wiper motor, so I didn't use that. And then these were some of the power seat motors, and they had these little outputs that are like what you'd find in a weed whacker. They're these like square shafts that are flexible. If you have a curved head weed whacker, these are in there, and the shafts flex. But again, it's not real great because it flexes around and moves, so it's hard to have a gear that's kind of located on that. So I pulled a bunch of those, but I didn't end up using those. And then this was the front windshield wiper motor, and you can see I ripped out the board because I didn't need speed control there. I just needed the input to the motor. But this one, the case was actually cracked. Water got in there and ruined it. So I didn't end up using this one. But I wanted to use this one because it was a little bit bigger of a motor, and the output shaft is directly connected to that worm gear that turns it down. So this would have been a great candidate had the had this case not been cracked by water, but it was cracked, so that was why I ended up using the power window motor. And what I did to get it on there, since there was a gear mounted to the end of it, I took, this gear was already mounted there, and the shaft itself doesn't turn, it's pressed into the case, just this gear turns. So I took another power window motor out of another door, and then I pulled the gear off of it, and that's what I used on this shaft, and I turned it down, and that's how I mated those together. But it would have been nice if this shaft just turned, because then I could have turned a coupling for that. But again, I couldn't use it, I had to use the gear, because the gear kind of forks inside. There's a little piece that goes down inside that mates it to a gear down inside, so I had to use the gear itself, and then that was why I just used another one off a window, and then turned down a coupling here, and then pressed it on. And then I had to actually tack weld that, because it was slipping, even though it was press fit. I should have honestly turned this, there was a male piece that goes in there, I should have turned the OD a little larger, so it would have been a tighter press fit, but you know, you live and you learn, so I just tack welded it, and it's holding for now. Doesn't look pretty, but it's working. And then again, this little coupling here, I just took the drill press, machined some flats with a 4-flute end mill, and then used a hand file to finish it down, and then punched them and drilled all these, and then tapped them 1/4-20, and then all I had was 1/2-inch set screws. These are a little long, so I actually need to get some shorter set screws. But I haven't put those in yet. I did pick them up, but I need to put some short set screws in, and then that'll get that finished out. And then I just made this little plate, and then these nuts are oversized. They're like 3/8 nuts, so I just used them as spacers because I had some of them laying around. And then this whole deal pivots on this bolt here. So if you're going to use the gearing of the back gears of the lathe, you don't want the back gears to turn this because it'll break that gear off inside. So you just loosen this nut, and then this thing moves out of the way, and you tighten back down, and it holds it out of the way, so that'll still turn. And then again, we just engage our half nuts here, and then there's the sensor there. It's sitting right on that little magnet, and then in here, this little magnet passes there, and that gives you your readout on the spindle there. So yeah, it was pretty cool. There's a little AXA tool post I got mounted up, and I'm working on making some bushings for the chainsaw mill. Yeah, so that was how it all came together. I'll show you a little bit of the insides of the panel in this video. I won't go super in depth into it, but if anyone's interested in it, I can kind of dissect it and show you how I made that panel. And again, this whole thing really cost me 80 bucks, and that was just for the electronics. And then everything else I just made out of some scrap stock, and that motor I pulled out of a car. So adding, if your lathe, and again, the whole reason I did this was because on the Atlas lathe, you have to change out the gears to change the feed, or the speed of the lead screw. And I didn't want to have to do that all the time for just normal turning. So that's why I added this external motor. That way I can turn, and then I can, you know, when I want to have really nice surface finish, instead of having to crank by hand, I can just set the speed and let it go. And I have really nice variable speed control with that pulse width modulator. It'll just run at whatever I set it at, and I don't have to constantly switch out gears and mess with stuff. But when it comes to turning threads, though, you do have to use the back gears because it has to be synced to the spindle. So for threading off, to disengage that. But just for normal turning, I think it'll be super handy having that nice fine control. So yeah, if anybody has any questions, let me know. But I was super tickled with how that came out. And again, it was cheap and easy, and if anyone's got a lathe and they want to add some speed control to their feed, that's the way I did it. I'm sure, you know, it's not exactly perfect, but I'm learning, and it was a good little project. Got to make some bushings with the lathe and stuff, so I was super happy with it. Yeah, hope you guys enjoy.